Okay, so now I'm going to solve a system of equations by a method called substitution. So here we have a system of equations. We have three equations with three unknowns. Our three unknowns are x, y, and z, and here are three equations. And to solve this system, what I'm going to do is I'm going to use substitution. And in substitution, what you do is you choose a variable that you want to solve for. I personally am going to solve for z right here. So I'm going to take this third equation, and I'm going to solve this third equation for z. So solving for z means adding 3x and subtracting 11y. So I would get z is equal to, is going to be positive 3x and minus 11y. And then I had a positive 20 on the right hand side already. So I just moved the negative 3x and the positive 11y over by adding and subtracting respectively, and the 20 was already there. So what I'm going to do now is I'm going to replace z in the other two equations, these z's here. I'm going to replace z in the other two equations with this expression, 3x minus 11y plus 20. So let's go ahead and do that, all right? So I'm going to take the first equation, x minus 3y plus 4 times, and instead of writing z, I'm going to write that expression that I have for z, and this is going to equal 7. And also I'm going to take the 2x minus 5y and the plus 10 times, and instead of 10 times z, I'm going to write 10 times that expression that I have for z. So let's see. The expression that I have for z is 3x minus 11y plus 20. So that's 3x minus 11y plus 20. That's what I have for z. So 3x minus 11y plus 20. And now what I'm going to do, I'm going to take this. I have a new system now. This is a system with two equations and two unknowns. Notice I only have two equations now, but I have only x and y as my unknowns. Z is gone. So what I'm going to do is I'm just going to simplify this by putting them both in standard form. Let's see. Distributing the 4 gives me x minus 3y plus 4 times 3x is 12x. 4 times negative 11y is negative 44y. And then we have 4 times 20 is 80. And this is equal to 7. And then on the bottom one here, I have 2x, a minus 5y, and a plus, and then 10 times 3x is 30x. 10 times negative 11y is negative 110y. And 10 times 20 is 200. All right, and this is equal to 21. Okay, so now I have these new equations without parentheses. I'm just going to combine like terms. So I'm combining this x with this 12x to make a 13x. I'm combining this negative 3y with this negative 44y to make a negative 47y. And then this 80 that's on the left-hand side, I'm going to bring that over to the right-hand side by subtracting 80 from both sides. And then you subtract 80 from this side, the 80 just cancels, but when you subtract 80 from this side, you get negative 73. All right, now, moving along here, we have now the bottom one, which is going to have me combining 2x and 30x to make a 32x. Combining a negative 5y and a negative 110y to make a negative 115y. And when I subtract this from both sides, let's see, I'm subtracting a 21 from both, or sorry, a 200 from both sides, and then 21 minus 200 is going to be negative 179. So there I have my two equations in their standard form. Now I'm going to continue here. I'm going to continue here solving one of these equations for the value of either x or y and plugging it into the other equation. So what I'm going to do is I'm going to go ahead and I'm going to solve this top equation for y. So solving this top equation for y, let's see, if I try to isolate y, I'm going to get y is equal to, it's going to be 13x plus 73 plus 73 all divided by 47. So if you solve this top equation for y, this is the value you get for y. I'm going to take that value for y and I'm going to plug it into this other equation here. So I'm going to have 32x minus 115 times y, which I just found an expression for. Let me make this parenthesis a little bigger. Times y, and this should equal negative 179. So the expression that I have for y was 13x plus 73 over 47. So now I have this equation here, and this equation only involves uh, x. I can solve this equation for x. Let's see what I'll do here. I'll have 32x. I'm going to distribute this negative 115 and this divided by 47 to both of these terms. So when I multiply negative 115 times 13, I get negative 1,495, and that's still over 47, multiplied by x. And when I multiply negative 115 times positive 73 over 47, I'm going to get negative 8,395 over 47. And this is still equal to negative 179, negative 179. All right, now what I'm going to do here is I'm going to clear the fractions. I'm going to multiply every term by 47 to clear out the fractions. This first term will become, well, 32 times 47 is 1,504 x. When I multiply this term by 47, I get 1,495 because the 47s cancel out times x. And when I multiply this by 47, I get 8,395. And when I multiply this by 47, I get negative 8,413. So there I've cleared the fractions. Now I'm going to combine like terms. Let's see here. The 1504 minus the 1495, x is just 9x when I combine these two. That gives me 9x. And I get 9x minus 8,395 is equal to negative 8,413. And then when I add 8,395 to both sides, 8,395, well, on the left side they cancel. I get 9x is equal to, and then on the right side, this sum gives me negative 18. So now I know, because I can divide both sides by 9, that x is equal to negative 2. So I have the value for x. Have the value for x. X I know is equal to negative 2 at the point where these three lines cross each other. The y value, let's see. We can find y because I found up here that y was equal to 13x plus 73 over 47. So bringing this down, let's go ahead and use that value of x to find the value of y. So that means that y is equal to 13 times negative 2 plus 73 over 47. 47. And I believe that's negative 26 plus 73, which is 41. I mean, not 41, 47, sorry. 47 divided by 47. And 47 divided by 47 is 1. So y is equal to 1. And now the last thing we need is z. Well, let's see here. Z, we had an expression for z all the way up here. Z, we said, was equal to 3x minus 11y plus 20. So we can take this expression that we have to give us our value for z, paste, and we see that z, it says then, is equal to 3 times x, which we found to be negative 2, minus 11 times y, which we found to be the number 1, plus 20. So let's see what we get. We get negative 6 minus 11, negative 17 plus 20 is equal to 3. So I have my ordered triplet that is the solution to this system. It's going to be negative 2, 1 for y, and z we just found out was equal to 3. Z equals 3. So there we have the ordered triplet. This is the solution set for our system, and that was the method called substitution.